right, geometry students, we are moving into our lesson about congruent triangles and something we call CPCTC. I'll explain more about what that acronym means in a minute. So we should, in this lesson, be able to use congruence in triangles to find the measures of their corresponding or matching parts. So in this lesson, we will cover what are congruent triangles. We'll talk about congruent statements, this acronym called CPCTC, and we will apply properties of congruence. So make sure you have your fill in the blank notes out and let's get started. So first off, let's talk about congruent triangles. Basically the definition of congruent triangles. Congruent triangles have the same shape and size. Same shape and size. This means that all corresponding or matching parts, that means the angles and the sides. So that means all three matching angles and all three matching sides have to be congruent. So here's an example of two congruent triangles. When triangles are congruent, we can write what's called a congruency statement. So in this one, triangle ABC is congruent to triangle DEF. And you'll notice angle A is congruent to angle D. Angle B, with the two arc marks on the angle, is congruent to angle E. And angle C, with three arc marks, is congruent to angle F. And we can also say side AB is congruent to side DE. Side BC is congruent to side EF. And side AC is congruent to side DF. What's cool about this is all of the letters in this congruency statement match up to each other. So angle A is in the same position as angle D, or vertex D. B matches up with E. B matches up with E. And C matches up with F. So order matters in this situation. We know that these letters have to line up in a specific way. A valid congruency statement must match all corresponding angles and sides. So once we know that triangles are congruent, we can use something called CPCTC. So let me talk about what this acronym means. It means corresponding, that's the first C, corresponding parts of congruent triangles are congruent. Basically what we said with a congruency statement. So by this property, CPCTC, corresponding parts of congruent triangles are congruent. We know if two triangles are congruent, that each pair of corresponding parts are also congruent. So we're going to demonstrate this given these congruency statements. So for the first one, number one, it says triangle JKL is congruent to triangle PQR. So we need to write all of the corresponding angles and sides that are congruent based on that statement. So for the angles, let's just start with J. J corresponds to P. Angle J, therefore, would be congruent to angle P. Second on the list is K, corresponding with Q. Angle K is congruent to angle Q. And angle L should be congruent to angle R. For the sides, again, sides have to be written in the same order as well. So let's start out with JK. Segment JK is congruent to segment PQ. Segment KL, So the second and the third letter in the first triangle should be congruent to the second and the third letter in the second triangle. So QR. And then let's do the first letter and the third letter. So JL should be congruent to PR in the second triangle. And if we want to write another valid congruency statement, all we have to do is rename the triangle in a different way. So I'll give a few examples. You can say triangle LKJ is congruent to triangle RQP. So that's an example. You can rewrite this a bunch of different ways. All I did was flip the letters order around. So for additional practice on this skill, go ahead and try out problems 2 and 3. Here are some other applications of this same skill. So we're going to look at numbers 4 and 6. So given in number 4, given that triangle STW is congruent to triangle BFN, we need to find each missing measure. So what this tells me is that angle S is congruent to angle B. It tells me that angle T is congruent to angle F. And it tells me that angle W, 3 arc marks there, is congruent to angle N. It also tells me that side ST is congruent to side BF. I know that TW is congruent to FN. And I know that SW, with 3 tick marks, is congruent to side BN. So I'm a pretty visual person, and if you are too, I recommend labeling everything you know based on those congruency statements. So let's find the missing measures now. For A, we need to know the length of BN. So its corresponding side would be SW, and we know that SW is 9 centimeters. So BN must be 9 centimeters. TW corresponds to side FN, and we know that FN is 14 centimeters, so TW must be 14 centimeters. For C, BF, that side matches up with side ST, and ST is 17 centimeters, so BF must be the same. Now for the corresponding angles. The measure of angle W should be the same as the measure of angle N. Angle N is 82 degrees. Angle W should be 82 degrees as well. Angle B corresponds to angle S. Angle S is 67 degrees. Angle B, also 67. The measure of angle F corresponds to T. And we're going to have to do a little extra addition, subtraction here. We know that angle B, let's say, is 67 degrees. And we know that angle N is 82 degrees. So to find angle F, we're going to go 180 minus 67 minus 82. And that's going to give us an angle measure of 31 degrees. Let's try a different application. For number 6, given triangle UVW is congruent to triangle TSR, we need to find the values of X, Y, and Z. So I'm going to label everything that I know. So I know UV corresponds to TS, they are congruent. I know that VW corresponds to SR, they are congruent, and UW corresponds to TR. So I can write 3 separate equations to find the values of X, Y, and Z. Let's start with x. I see that 12x minus 7, the length of UV, should be the same as TS. So that means 12x minus 7 should equal 53. And I'm going to go ahead and solve that equation for x. Add 7 to both sides. 12x is equal to 60. Divide both sides by 12. And you get x equals 5. For my second variable, I need to find the value of y. I see that SR is 5y minus 33. Its corresponding congruent side in the other triangle should be VW. VW is 57. So I can write the equation 5y minus 33 is equal to 57. And I'll go ahead and solve this equation for y. 5y is equal to 90. Divide both sides by 5. And y is equal to 18. Lastly, for z, I see that side UW is 3z plus 14 units. And I see that its corresponding congruent side is TR, and TR is 50. So I can write the equation 3z plus 14 equals 50 and solve that equation for z. Three z is equal to 36. Divide both sides by 3. And z is equal to 12. So that was kind of a longer problem, but I was able to find the measures of all of the sides, or to find the values of the variables for all of the sides using congruency statements and using CPCTC. Corresponding parts of congruent triangles are congruent. For additional practice with this concept, try out problems 5 and 7 through 9. So that is it for this lesson. Thank you so much for watching. Make sure you try out the additional practice problems and check your answers with my filled-in notes. That's Content Library Topic 4 notes. Ask for support in Math Help Desk if you need it, and have an awesome day.